Example 1 is a question about melting a solid and then recasting it. This type of questions usually appears in the topic of mensuration. From the information given by the question, there is a right circular cylinder of base radius uppercase R cm. Its height is 20 cm. This cylinder is melted and recasted into 16 smaller right circular cylinders of base radius lowercase r cm. We do not know the height of the smaller right cylinders in this moment. In part A, we have to find the ratio of lowercase r to uppercase R. From the information given by the question, the base area of the larger circular cylinder is 4 times that of a smaller one. That means we can write an equation in this way. 4 times pi lowercase r squared equals pi uppercase R squared. 1 mark will be given for giving the correct relationship between the base areas of the larger and smaller circular cylinders. We eliminate the pi's on both sides. Then both sides are divided by 4 uppercase R squared. We have lowercase r over uppercase R whole squared equals 1 over 4. Taking square root on both sides, we have lowercase r over uppercase R equals 1 over 2. That means the ratio of lowercase r to uppercase R is 1 to 2. 1 mark will be given for the correct answer. In part B, since the original larger cylinder is melted and recasted to 16 smaller cylinders. In this process, the volume of the original larger cylinder is equal to the total volume of the 16 smaller cylinders. We first let HCm be the height of a smaller cylinder. And from part A, we know that the ratio of lowercase r to uppercase R is 1 to 2. That means uppercase R equals 2 times lowercase r. We can write down an equation now. The total volume of 16 smaller cylinders, which is 16 times pi lowercase r squared h, is equal to the volume of the original larger cylinder, which is pi uppercase R square times 20. 1 mark will be given for giving the correct relationship between the volumes of the larger and smaller circular cylinders. We can eliminate pi on both sides first. Then, we can substitute uppercase R by 2 times lowercase r. 1 mark will be given for correctly applying the result of A. Solving the equation, we have h equals 5. That means the height of a smaller circular cylinder is 5 cm. 1 mark will be given for the correct answer. In MC Question Tutor, this is a question about the area of a sector. From the information given by the question, we know that OA is 18 cm, OC is 30 cm, and the area of the shaded region is 192 pi cm squared. We have to find out the angle of the sector first. We let it be x degree. Since the area of the shaded region is 192 pi cm squared, the area of the larger sector minus the area of the smaller sector is equal to 192 pi cm squared. We can find out the angle of the sector by this equation. The area of the sector is equal to the angle of the sector over 360 degrees times pi r square. So, we can write down this equation. The radius of the larger sector is 30, and the radius of the smaller sector is 18. Solving the equation, we have x equals 120. Statement 1 is correct. We know that the angle of the sector is 120 degrees now. It will be easier for us to determine whether statements 2 and 3 are correct or not. By using the formula, the area of sector OAB is 108 pi cm squared. Statement 2 is correct. Since statements 1 and 2 are correct, the answer must be option C. But let me show you why statement 3 is not correct. We have to find the perimeter of the shaded region. The perimeter equals the total length of AC, BD, arc AB, and arc CD. The lengths of both AC and BD are equal to 30 minus 18. The arc length is equal to the angle of the sector over 360 degrees times 2 pi r. The angle of the sector is 120 degrees. The radius of the smaller sector is 18, and the radius of the larger sector is 30. Simplifying the expression, we have the perimeter equals 24 plus 32 pi cm. So, statement 3 is not correct. That's why the answer is option C.